In this video, we're going to talk about graphing certain kinds of exponential functions. And really, the simplest kind of exponential function just has the form f of x equals a to the x, where a is greater than 0. And we looked at one of these in the last video. In fact, we graphed the function f of x equals 2 to the x in the last video. And we noted that it went through the point 0, 1. And really, the reason for that was because when we plug in 0 for x, we get 1 as an output, right? 2 to the 0 is 1. Okay, well, you get a similar thing happening if you graph 3 to the x or 10 to the x. The big difference, now they all go through this point 0, 1, but the difference is 3 to the x is a little steeper over here. It grows faster than 2 to the x, and it actually goes down toward the x-axis faster to the left. Now, none of these ever actually touch the x-axis over here, but they get closer and closer to the x-axis. 10 to the x is even steeper, and it gets down toward the x-axis even slower over here. But notice all of these functions, as you go left to right, they're going up. So we have what's called exponential growth. Okay, I'm not going to write the whole word exponential, but we get exponential growth because as you go left to right, the function's going up. Now, another point I want to make is that you don't need to have a whole number like 2 to the x or 3 or 10, like 2, 3, or 10. You could graph, for example, like 1.5 to the x. Okay, 1.5 to the x, you know, looks very similar to these. Only notice it doesn't grow quite as fast as 2 to the x. Okay, again, it goes through this point 0, 1. Okay, now 1 to the x, that would just be a straight line here because 1 to the x is the same thing as just 1, right? Graphing the function 1, that's a horizontal line. Okay, but what about if our a, okay, here we've chosen values of a that are 10, 3, 2, 1.5, and 1. What about if our a is less than 1? For example, what if a is 1/2? Okay, well, I want to make a little note here. Okay, let's make a little note here. That 1/2 to the x is the same as 1 to the x over 2 to the x. Okay, that's just the properties of exponents. Okay, and 1 to the x is really just 1. Okay, no matter what x is, 1 to the x is 1. Okay, so 1/2 to the x is the same thing as 1 over 2 to the x. And if you remember the properties of exponents, this is the same thing as 2 to the negative x. So I want to point out 2 to the negative x really is the same thing as 1/2 to the x. Okay, we could do a similar thing. Let's try it for like 1/5 to the x. Okay, it's the same thing as 1 to the x over 5 to the x, and that would be 1 over 5 to the x, which is the same thing as 5 to the negative x. So if you see something like 2 to the negative x, you might think, is that really have this form a to the x? Well, yeah, it does, but the a would be 1/2. Okay, because 2 to the negative x is like 1/2 to the x. So this has that form a to the x. Okay, same thing, 5 to the negative x is the same thing as 1/5 to the x. And by the way, you could write these as decimals. 1/5 is 0.2. Okay, 0.2 to the x, and 1/2 to the x is 0.5 to the x. Okay, so if you see something like 0.5 to the x, recognize it's the same thing as like 1/2 to the x, and that would be the same thing as 2 to the negative x. Okay, so what do these functions look like? Well, let me just say, if you're going to do 2 to the x, 1/2 to the x is really the same thing as 2 to the x, only it's flipped across the y-axis. Okay, and that has to do with the fact that 1/2 to the x is really the same thing as 2 to the negative x. So if we're gonna draw this, let's see if I can do this well here. Okay, 1/2 to the x looks like this, and that's the same thing as 2 to the negative x. Notice it's just the flip of this across this line. So another way of writing that would be 0.5 to the x. Okay, in here we get for this function we get exponential decay. Okay, as we go left to right, the function is going down. Okay, instead of growing, it's going down. So we're getting exponential decay. Now, what about, let's say, 1/3 to the x? Well, 1/3 to the x would be the flip of 3 to the x. Okay, 1/3 to the x would look something like this. Okay, and then, so this is 1/3 to the x. Okay, and maybe 1/10 to the x would look something like this. Okay, it's not supposed to cross below the x-axis there. I made a mistake there, but 1/10 to the x would look like this, or that's really 0.1 to the x. So notice a couple things. If your a here, like 1/2 or 1/3 or 1/10, if your a is less than 1, Okay, but it's still positive, right? Notice the 1/2, 1/3, 1/10 are less than 1, but they're still positive. We get what's called exponential decay. And if your a is bigger than 1, we get exponential growth. And moreover, if your a is bigger than 1, so like for these numbers 10, 3, and 2, the bigger your number, the steeper the graph is going to be. Now over here, if your a is less than 1, it's just the opposite. The bigger your number, so like 0.5 instead of 0.1, the more gradual it's going to decline. Okay, so anyways, this is 0.5 to the x, this is 0.1 to the x. Okay, 0.5 is bigger than 0.1, and it's actually more gradual here. Okay, so that's exponential growth and exponential decay. One last thing I want to point out is that what do you do in a situation like this? What about f of x equals, let's say, 2 to the 3x? Okay, 2 to the 3x. Does that have the form a to the x? Well, notice we have a 3x up there instead of an x, but actually we can write it in this form. In fact, 2 to the 3x is the same thing as 2 to the 3rd power to the x. Okay, in fact, if you tried to simplify this expression, isn't this really 2 to the 3x because you multiply? Okay, but actually 2 to the 3rd is 8, so this is 8 to the x. So 2 to the power of 3x is the same thing as 8 to the x. Okay, so recognize that 2 to the 3x is the same thing as 8 to the x. So that our a in this case would be 8. Now what about if we looked at f of x equals 5 to the negative 2x? Well, that's the same thing as 1 over 5 to the 2x, and that's the same thing as 1 over 5 squared to the x, right? Because 5 squared to the x is the same thing as 5 to the 2x. So that's 1 over 25 to the x. And you could rewrite this as 1 to the x over 25 to the x, and it's 1/25 to the x. So 5 to the negative 2x is the same thing as 1/25 to the x. And notice what we would have here is exponential decay, because this a here, okay, this is of the form a to the x, a is less than 1. Okay, it's a number between 0 and 1. Okay, so if you have a negative exponent, okay, or if your number is here is less than 1, then you're going to get exponential decay. Okay, so but just remember these principles here, that like 1/2 to the x is the same as 2 to the negative x, 1/5 to the x is the same thing as 5 to the negative x.